All right, we've officially reached our last section of chapter 6, and I mentioned it back in chapter 4 that we'd be coming back to another type of transformation. And this time, instead of producing congruent figures like translations and reflections and rotations, it's going to produce similar figures. So what we're going to talk about today is a dilation. So a dilation is a transformation that stretches out or shrinks a figure to create a new similar figure. So kind of like when your eye doctor dilates your pupils, they're making them bigger. Other cases, some other things might make your pupils smaller, so they're dilating. So it has the same meaning. The blank of a dilation is the ratio of a side length of the image to the corresponding side length of the original figure, and that's the scale factor. So we've used scale factor before dealing with similar figures. And before we've talked about it like a fraction, and you'll see in this case today we're going to talk about it kind of as a whole number, like what number is being multiplied to get the new image or go back to the regular figure. So it says you can describe a dilation with respect to the origin with the notation. We have xy, like we always started with before, and an arrow, and then kx and ky, where k is the scale factor. So you can tell we're going to be multiplying each x or y by the same number. If 0 is less than k is less than 1, so if k is between 0 and 1, it is a reduction. We're taking a figure and we're making it smaller. If k is greater than 1, the dilation is an enlargement. We're making it bigger. So we're just going to go through a few different examples. It's fairly simple content, just a few different ways that you're going to have to be able to apply what you know. So it says to draw a dilation of quadrilateral ABCD with vertices 2, 1, 4, 1, 4, negative 1, and 1, negative 1. Use a scale factor of 3. So we have our original figure, and what we're going to do is multiply everything by 3 because that's the scale factor. So my rule is xy is going to dilate to 3x, 3y. So if I go through and apply that rule to all my points, all I'm doing is multiplying each x and each y by 3. So I get 6, 3, 12, 3. 12, negative 3, and 3, negative 3. And if I go plot those points, I can tell if that's going to look right. So there's the first one, 5, 10. I'm going to have to go off my graph a little bit. There's my second one. There's my third one. Here's my fourth one. And you can tell that it definitely enlarged the figure. You can tell they're the same shape. And I could check to see if they're similar by seeing if this length is proportional to this length. This length is proportional to this length, and it should because we multiplied the same thing, everything by 3. The next question says, think about it. What would happen if we only used a scale factor of 3 with the x values and the y value stayed the same? Would it still result in a similar image? And I'm not going to tell you that answer right now because I want you to think about that. So it's saying we're going to use a scale factor of 3 with the x's, but the y's are going to stay the same. So think about what would happen if we did that and if it would still be a similar image, and we'll come back to that when we're together as a class. All right, example 2 says, find the coordinates of L, M, and N so that triangle LMN is a dilation of PQR with a scale factor of 1/2. So now, if you're someone that writing the rule helps you, I'm taking XY and multiplying everything by 1/2. Hopefully you can tell this is going to be a reduction. We're going to be taking that shape and pretty much taking it and dividing it everything by 2, making it half the size. So if I take everything times 1/2, I get negative 1, negative 1/2. And it's okay to get fractions. I get negative 1/2, 0, and I get 0, negative 1/2. We don't have to draw anything. We just have to be able to apply that rule to those points. All right, and we just have 2 more examples. So example 3 says, tell whether each set of coordinates represents a dilation from triangle ABC to triangle DEF. If yes, state the scale factor. So we're checking to see, is there a dilation going on, as opposed to maybe a translation where we add and subtract, or a reflection where we change the signs. So let's see what's going on from each point to its corresponding point. If I look from here to here, and here to here, and here to here, if it's a dilation, I have to look for something being multiplied by everything that's going to be the same throughout. So hopefully you can recognize here, everything is being multiplied by 3. Yes, 0, 0 stays the same, but that's going to be the case no matter what, because if you multiply by or 0 by a number, it's going to just stay 0. So this is going to be yes, and the scale factor is 3. Now let's look at B. If we look at B, I see a pattern. I see that from every x to every y, from every x to the new x and y to the new y, everything is adding 2. So it's going 1 plus 2, 3 plus 2, 4 plus 2, 11 plus 2, and so on. So you might think, well, yeah, this is a dilation because everything's increasing by 2. But remember, a dilation is multiplication. So actually, this wouldn't be a dilation. This would be a translation where the x's are increasing by 2, the y's are increasing by 2. And maybe you remember that means 2 to the right and 2 up. So that would not be a dilation. So just be careful with ones like that. All right, last one, example 4, says tell whether the dilation from the purple triangle to the blue triangle is a reduction or enlargement. Then find the scale factor. So the great thing is it was colored when I made this worksheet, but of course, on a black and white copier, it's not. So the purple one is the big one. The blue one is the small one. So if we're going from the purple to the blue, and we're wondering if it's a reduction or an enlargement, hopefully you can all see that that's going to be a reduction because it's definitely getting smaller from this one to this one. To find the scale factor, it's just a little bit harder than what we've been doing because the points aren't written out for us. We have to find the points on our own and then compare the old points to the new points. So let's take a look here. I'm going to label my points. This is 2, 6. This is 6, 2. And this is 2, 2. Now I'm going to look and see what are the points of my smaller triangle. I see 1, 3. I see 3, 1. And I see 1, 1. So if I look at that from this point to this point, this point to this point, this point to this point, hopefully you can see that that scale factor is going to be 1/2. If you were thinking 2, that would be if we were going from the small triangle to the big one. In that case, it would be an enlargement. So if you're saying it's a reduction, remember that your scale factor is going to have to be between 0 and 1. So it has to be less than 1. The last part we're not going to do together, but I challenge you guys to try it, is to describe the 2 transformations that take place from one set of points to the other. So what's happening from these points to the second set of points is 2 transformations. Maybe it's a dilation times 1, or sorry, not 1, maybe times 5 and then a reflection. Maybe it's a translation down 2 and then a dilation. So think back to everything we've learned, dilations, translations, and reflections, and see if you can figure out what the 2 transformations are that you need to use to get from the first set of points to the second. So it's kind of like a guess and check puzzle you're trying to figure out. If you figure out one of these, let me know and I'll give you a Cougar Kudos for that. So once you finish these notes, you are welcome to move on to the practice worksheet. And when you finish the practice worksheet, check your answers, then you can go back and take the graded quiz on Schoology. It is only worth 8 points, so it's nothing to stress about, but if you know what you're doing with dilations, that should be an easy way to earn 8 points.